Welcome to the Module 2, Part 3, Test Review Solutions. Here we are going to go over questions 9, 10, 11, 12, and 13. We're going to display question 9 now. Alright, determine whether the following situations are discrete or continuous. To do this, we want to look at the domain and range, right? What I wrote here is part of the solution, but it wasn't provided, okay? So here, the first one, Jack has 12 bags of hot Cheetos. Every day he eats one bag. The relationship between days and the hot Cheetos. I noticed that the domain here is days and the range is the bag of Cheetos. Is domain days? Is days continuous or discrete? It is, oops, that should be continuous, sorry. Right? That should be continuous. Because can you have half of a day? Yes. Can you have a quarter of a day? Yes. It's still a day. Time is continuous in that sense, right? The range is the bag of Cheetos. Next, the deadly virus is released into a population. The amount of people infested is reported to tripled each minute. The relationship between minutes and the effective people is, here the domain, which is blue, is each minute, right? Which is the input. The output is the amount of infected people. So the range is the red, the infected people. The domain, we only look at the domain. Is the domain discrete or continuous? It is continuous because minutes, you can have 0.5 minutes, 1.5 minutes, right? It's still a minute. Next one, cherry blossom falls at a rate of 5 centimeters per second. The relationship between seconds and centimeters is, right? The domain is in seconds, right? The range is in distance, right? So the domain here is seconds. Can you have 0.5 seconds? Yes. Can you have 1.5 seconds? Yes, right? It is also continuous. Notice days, minutes, and seconds are all time values. Time itself is continuous, okay? Next, question 10. I just want to bring this to your attention. Question 10 was removed because it's actually a compound interest problem, okay? This is just a solution if you would like to see it, but it's not going to be on the test, right? P is for the principal, which is the starting, right, which is 2000. The R was 0.04 growth. N is 12 because it's monthly. T was 1 year. Plug this in, plug it into your calculator. That's only if you want to see it, but it's not going to be on the test. Question 11. Okay, we have this image, and we're going to be asked to compute its equation. Okay, so what I did is I put it into two charts. The black chart here is going to be f of x, which looks linear, and the gray part here is going to be for g of x, which looks exponential. I set up two charts to just help me deal with the problem much easier. Alright, so I saw that the common difference here, I did the slope. I saw m is equal to 3. Right, from the slope here. Here I had to set up the equation, and I saw that r is equal to the square root of 7. Doesn't work out so well, okay? Right? Once I do that, I can plug it in. I notice that the y-intercept for both functions are both 7. So the first one is f of x, which is the black one, which is linear, 3x, because 3 is the slope, 1 is the y-intercept. Next one, g of x, is equal to 1 because that is the 0 term, and that's the r, which is square root of 7 to the x power. Next, this is question 12. A car initially costs $32,000 and depreciates at a rate of 20% of its value every single year. How much will the car be worth after 4 years it was purchased? Notice that f of 0 is $32,000 because that is the 0 term for the new laptop. It's depreciating, it's decaying at 1 minus 0.20 because it's losing 20%. So the R value is 0.80. So once I get the R value here, which is 0.80, and the F of 0, which is 32,000, I can plug into the equation. I use the 0 term exponential equation because I have the 0 term here. Plug that in. I get f of x is equal to 32,000 parentheses 0.80 to the x power. right? This comes from the information that I got here. Now, to do it for the fourth power, to the fourth power, you set the x to 4. Plug this in, you should get f of 4, right? Right? You're evaluating x equals to 4 is equal to $13,107.02. Okay, that is how much the car has lost. That's how much the car is worth after 4 years. Last one. This is third, right? And this is the Richard buys a laptop, right? So that's question 12, right? That's the car, and this is the Richard problem. Richard buys a new laptop for 1,800. The laptop depreciates in 8% now each year. Okay? Same thing here. Okay? I write the first f of 0, which is 1,800. That's the 0 term for the laptop. It depreciates, so it decays, which is going to be 1 minus 0.08. So the R value here is 0.92, right? Notice the difference. This one was R equals to 0.80 because it's 20%, but this one is 8%, so it is 0.92. Remember, you always have to do that 1 minus the decimal for the decay, right? Plug this in to your 0 term of the exponential equation. So y is equal to 1,800, right? Parentheses 0.92 to the power of x. All right, let's look at 13 now. The line graphed on the coordinate plane below shows the relationship between the distance, meters, and times a runner records for his or her speed. What is the runner's speed in meters per second? So we have the runner in this chart. So what I did here, what is the runner's speed in meters per second? What I did is I looked and I used the graph. Okay, I saw that the change in y is 2, the change of x is 4. So my average speed is defined by the slope, which is m, the average speed or the slope, is equal to change of y over the change of x. I saw from my visual part of the graph, the change of y is 2, which is red, the change of x, which is the green, which is 4 meters. I simplify, it becomes 1 meter over 2 seconds. So the runner speed is 2 meters for every single 1 second. Okay, so there you go. Those are all the solutions for the Module 2 Review Part 3.